Good afternoon, everyone. My name is Abdelhak Belhi, and I'm from Qatar University. Today, I will present my team's work regarding the integration of blockchain technology with enterprise information system applications. This work is undertaken within the Supply Ledger MPRP project, which I am part of, and which is funded by Qatar National Research Fund and Qatar Railways Company. As an introduction to the subject, the enterprise information systems applications we are interested in are related to the supply chains, which are huge networks involving a lot of actors to transfer goods and services. These dynamic and complex networks are the backbone of our modern life, and any disruptions in these chains may induce huge consequences and losses. And thus, we identified several challenges related to increasing the efficiency and security of supply chains. These are mainly related to the transparency of transactions, traceability of goods, peer-to-peer trust, and resilience. Blockchain is a technology that made its success in financial technologies through the Bitcoin cryptocurrency. From then, it has been successfully used in other domains related to Internet of Things, supply chains, etc. Smart contracts, which enabled computer code to be executed within blockchains, allowed the development of decentralized applications. Our goal in the Supply Ledger MPRP project is to take advantage of blockchain and smart contracts to increase the efficiency, security, and transparency, as well as traceability in modern supply chains. Since supply chains are very complex distributed processes, they often face several types of risks such as downtime, security breaches, and forgery. Our goal in this work is to propose a new way of integrating blockchain in the context of supply chain management by developing an architecture as well as a proof of concept system based on open source software. The system relies on a smart contract to manage critical supply chain transactions. As we can see in this example related to logistics supply chain, a lot of actors and documents are involved in order to transfer goods and services in supply chains. Blockchain smart contracts may be used to manage the different workflows, enabling problems to be discovered quickly and solved in a timely manner, as all transactions are executed in a decentralized environment. From the technical side, and to ensure that the system based on blockchain is sound and fully effective, blockchain has to be the only source of data. However, this is not realistic in the real world, as blockchain is not meant to be used as a relational database. Blockchain is very slow in committing transactions and not suitable for real-time transactions. This complicates indeed the integration of blockchain with existing platforms. In this work, we investigate the integration of blockchain with both existing and new enterprise information systems. We present our proof of concept integration, which is developed using the Hyperledger Fabric blockchain platform and the Odoo open source ERP enterprise information system framework. So we mostly focus on a broker-based integration, which consists of a software component that is integrated with Odoo and communicates with the blockchain network to manage Odoo workflows and processes using customized smart contracts. We present our proof of concept, which is based on an exemplar small-scale manufacturing supply chain, and demonstrate how can blockchain be integrated into this scenario. We present two integration architectures. The first one is what we call interoperability and is only suitable for fresh enterprise information system installations, where blockchain integration is happening from the beginning. A common data model based on XML or JSON is required to specify data structures as well as business logic. This common representation is then translated to the ERP framework and to the blockchain as chain code. Smart systems communicate with each other to synchronize transactions using two modes. The first one is fully synchronous and only suitable for very critical transactions, as transactions has to be first committed to the blockchain. The second mode, the asynchronous one, is for less critical transactions. As a proof of concept, we set up a small-scale manufacturing supply chain involving 5 actors collaborating with each other to manufacture a machine. The Odoo interface you see on the left is related to the workflow between the customer and the designer to provide a design. The workflow is fully managed using smart contracts. Smart contracts programming is object-oriented, as data structures and methods managing data are defined in classes. Smart contracts can be written in various languages, such as Golang and JavaScript. Odoo is, however, developed using Python. As per the business logic, and to ensure a common representation of the rules, we used a library that represented rules using JSON file, as can be seen in the figure above. The figure below shows a snippet of a smart contract written in JavaScript. As per our results, we concluded that the Python Hyperledger SDK is not very mature. Despite that, we were successful in synchronizing both data and rules between the ERP and the blockchain. We implemented various data and rules integrity checks to check the data status in both platforms at any given time to ensure the soundness of the overall system. In this figure, we can see that the data in the ERP and the blockchain is not the same, and thus the Odoo interface trigger a warning. And the second one, we can see that the data bit in the blockchain and the ERP is similar, thus the Odoo interface sends an information bullet saying that the data is similar. The second architecture we propose is suitable for existing information systems that have the ability to be integrated with third-party software using APIs. Our idea is to transform critical transaction management from being handled in centralized environments to being managed by smart contracts. In order to achieve this, smart contracts have to be written for each critical transaction. This solution has only one mode, the synchronous mode, as transactions are fully managed by the blockchain, as can be seen on the figure on the right. This is showing indeed promising results in our tests with Odoo, but more work has to be undertaken with other platforms to achieve effective integration. Finally, we have showed in our presentation that blockchain is a decentralized platform that can address many challenges in information systems, enterprise information systems, and showed that it can manage business transactions, especially in environments where a lot of actors are involved. We have reviewed the main characteristics of blockchain technology and its enterprise information system application domains, and presented an application of enterprise information systems using one of the leading private blockchain platforms, which is a Hyperledger Fabric. We presented 2 different architectures and proposed to integrate blockchain in the enterprise information systems. All our experiments were undertaken using open source software, where we successfully integrated Odoo and Hyperledger Fabric for our proposed manufacturing supply chain use case. In the future, we will focus on exploring more features of the blockchain platforms and perform a comparative study of the performance of different available blockchain platforms. Thank you for your kind attention.